Hi everyone, and welcome to another restoration at Mr. Carlson's lab. Let's get started. Let's check out this old General Electric dual speaker radio. So I guess there's going to be two speakers in here. And it's also long range. So we'll see why it's long range here in a moment. So this is another one of those interesting barn finds. I went to this big barn and the fella had tons of these radios on his shelf. And this was one of the nicer ones. Some of them were pretty tattered. So I don't know what this is on the top. It's sticky, feels like tape residue. So maybe we can get rid of the tape residue and make the case look rather nice. They could have done a little bit of a nicer looking job with the speaker, kind of a tweed look to the speakers. I don't know, I guess would probably fall in line with some of those early guitar amplifier, the tweed look. But I don't know, it really doesn't set off the look of this radio all that well. I guess they did it to match the very realistic looking wood grain background in the the radio style. Why they did this stuff, I tell you. Anyways, it has a volume, tone, and this would be the tuning control here. The plastic is rather scuffed up, so we'll see if we can buff that up, polish that plastic up a little bit. So this should be an interesting performer because it is a long-range radio. Now, I haven't had this thing apart. It does have a very interesting kind of perfumey odor that comes out of this thing. So just moving it around, I can smell this perfumey smell. So maybe it was somewhere where perfume was sprayed or something like that. So we have a 12BA6, 12BE6. So this is an RF amplifier. All right, that would be the RF amplifier. How do I know that? Well, because I've worked on enough of these older radios to just recognize the tube complement. So RF amplifier and the 12BE6 is the mixer. We would have the 12BA6 again as an IF amplifier. This looks like a 35. Let's zoom on into this. 35W4, which would be a rectifier. 35C5 would be the audio output tube that drives the speaker. And then we would have the 12AV6. That does three things. So that's a detector. That's in the AVC tube, and that is also an audio amplifier. So it does three things, this one tube here. So the reason they call this long range is because of this one tube, right? Because it has an RF amplifying stage in it. Now, I haven't opened this thing up, as I say, but I can see what looks to be a rod antenna through the holes there. I don't know if you can see that. Right, so you see that kind of a ferrite style antenna. Leon's Teleservice. So obviously this thing was serviced in Vancouver, BC at some time. Of course, Leon's was a furniture place here. Kind of neat. There's a little bit of local history, I guess. And all the screws have been removed. So there is no screws in here, but it looks like the back locks in place and it has one of these earlier interlocking style plugs that didn't allow you to power the thing up with the back removed. And the reason they did that is because there's no transformer inside these sets. These are known as transformerless sets. So the chassis itself, if it had a chassis, would be live. I don't know if this is a chassis style radio. It may have a circuit board inside. It looks like it's one of the newer styles. And you can see here there is absolutely no metal connection. This is just, for looks here. These are plastic knobs. So there is no metal connection to the outer world on this radio whatsoever. And this is when they started to become a little bit more safety-minded because, again, these plugs here, you can plug them into the wall either way. You can plug it in this way or you could plug it in this way. So on the older radios, you had a 50-50 chance of plugging it in and making the chassis hot, depending on which way you plugged it into your wall outlet. So this is completely isolated from the outer world at this point. And that's kind of nice because, if you were to, fix up one of these radios, you're a lot safer than one of the radios. A lot of the earlier All-American 5 or All-American 6 style radios would have screws on the bottom. So there was still a form of chassis connection to the outside world. This one is completely isolated from it, so there's no metal to touch inside this radio whatsoever if the back is on it. So much safer design. Anyways, what I'm going to do here is get some screwdrivers and we'll carefully pry the plastic cases to not wreck the back side of the radio here. Let's take a look inside and see what's inside this thing, and then let's bring it back to life again and see how long range it really is. Let's make this thing work again. All right, let's take a look inside this radio. And yes, it does smell perfumey. Wow. So I think careful enough here. I really don't want to destroy the backside of this radio here, so very carefully open that up. Gotta be so careful because the plastic is so brittle on these older radios, right? It is an early circuit board design. Not too bad. Not too bad looking inside at all. It has that, wow, is that ever perfumey? I can't even describe that. It's almost like a floral, kind of a fruity type of smell. So this is obviously kept somewhere where maybe either perfume or maybe some form of hairspray or something was used. It's really like very perfumey. So yeah, it has the old rotting foam in there. Do something about that. And all the tubes seem to be in place. Filter cap over here, and there's that rod antenna. And of course the dual speakers. Now, what's really interesting is it has two different speakers. You can see this one here is different than this. So obviously they were really trying to play with the tone in this. Either that or somebody at some point has been in here and has replaced a speaker. It looks like it fits perfectly though. It's clipped in. But this side here doesn't look like it's clipped in, but it looks like it could clip in. Yeah. See, this has got a much larger, this speaker here is much larger than this one, so this one here would be the one that would fit on this side, so I think it's original. So let's put a line cord on it and see if it comes to life. I'll grab a line cord here. Actually, I'll just use my the line cord that I have with my isolation transformer and variac supply. Boy, that is really crooked. That board is really got a bit of a twist to it there. That won't affect its performance or anything, but anyways, yeah, let's get a line cord on this. I have this attached to my isolation transformer and current limited variac supply, which you'll see right here. So the dim bulbs are in line, so what I'll do is I'll just turn that on. Right now it's just at full line voltage, but it's current limited. As we can see, the dim bulbs are lit just a little bit, but the radio is off. That's normal for this because I want just a little bit of glow so I can very easily see a difference here. So what I'm going to do is turn the radio on, and we want to keep an eye on the bulbs and see if they change at all. All right, so here we go. And there's absolutely no change in the bulbs. So what that tells me is one of the vacuum tubes here is open. So what we're going to do is take the chassis out of this thing, and we'll start troubleshooting the tubes right in circuit, and I'll show you how to do that. Let's try and get the circuit board out of this thing, see what we're up against here. So the very first thing to be done is to take these knobs off. So usually in all of these radios, the All-American 5 and All-American 6 radios, the knobs are usually part of the chassis or the circuit board. Boy, that is in there good, but it came out okay. Look at that big dust washer in there. That's kind of neat. I guess that's to keep dust from getting into the dial here. So there's another one here. Look at that. It's really long. There's nothing metal about these. These are all plastic. Very, very, very light. I don't know if you can hear that. It's plastic. And that one's quite a bit shorter. Looks like all the shafts on the potentiometers are plastic. So this dial is going to be attached to this chassis somehow, I imagine. Let's see if we can pull this out. It's clipped in here. It feels like there's something holding this in. Let's see here. Looks like there's a clip down in there. So I'll just remove these two tubes. And this one. Yep, there's a clip. See that little clip right down in there? Gotta press that back and move this out. So let's see here. Yep, that is it. Yeah, I can feel the dial string is definitely holding this, so I don't want to pull on that. So put that like so. Now, usually these plastic faces, if you need to remove this to get the chassis out, usually they'll come off relatively easy. Let's see if this is... Usually you can push down and pull forward. Let's see if this is going to happen. Look at that. There you go. So don't be fooled by this. Don't pry up on these. This is designed to be pushed down and pulled forward. If you pry up on this, you'll crack the case and you'll also wreck this piece of plastic here. Just needs a good polish. That's pretty rough. So now what we need to do is turn this. So I'm going to push the chassis in just a little bit and give that a twist. And that should come out of there. Yeah, I can definitely feel it. It's ready to come out now. So all I need to do now is desolder those speaker wires. And I have my iron warm. So I'll just get this in here. Hopefully these aren't put in here too bad. No, it just looks like a really long wire put through the speaker there. Green on the top, black on the bottom. And there we go. Not too bad, not too bad. So let's see if I can get this thing out of here now. Anything else holding this? Oh, there is more holding this. There's a screw up here I see on the antenna. Let's get that out of there. Usually they're not in too incredibly tight. I could probably use the correct size screwdriver. That would make life a lot easier, wouldn't it? And let's put this in here like so. Pull this back. And that looks, it feels like it's stripped or something in there. It's driven into the foam. So I'll pull in. There we go. That's feeling pretty good. And here it is. It is out of there with the speaker wire trapped around the top. Pardon a bit of the road noise in the background. Some noisy vehicles around here at this time of the day. So there we go. Looks like we got the printed circuit board out. All right, so I'll get the screws and all this stuff out of the way here, and we'll take a closer look at the circuit board. Here's a closer look at the circuit board. And as you can see, it's a little dusty and dirty, so I can probably take this out to the shop. That actually looks like it's on there pretty good. So what usually cleans these boards off very well and isn't harmful to the surrounding components, if you're careful of course, is WD-40 in a toothbrush. So it usually cleans these boards off very, very well and makes them look like brand new again. So that's what will end up happening here in a little bit. So now we found earlier in a test that obviously something in the filament circuit is open because nothing is drawing current. Now, in order for the radio itself to actually draw current, the tubes have to warm up and get hot. The rectifier has to come into emission, so it has to get nice and hot before the actual radio will pull current aside from the filament current itself. So we need to find a break in the filament string here, and that's pretty easy. So I'll draw that up for you here in just a moment. Another thing I'd like to mention is you'll see how there's kind of a ring around the getter compound here. So that little chocolatey brown colored ring usually indicates that the tube has been very, very hot. And, it's definitely, the metals inside have been outgassing through its service life. So that chrome spot that you see inside of the tubes, and sometimes it's a little darker than chrome, those little spots are designed to be there to absorb the impurities that basically outgas from the metals as the tube is operating through its service life. As the tube's getting hot and cold throughout its service life, being turned on and off. And of course, when the tube is actually in emission, the internal structure gets very, very warm, not just the filament, but the actual plate and everything gets warm in there. And then the metals themselves, they let out impurities because, it's just the nature of the way things are. So when the tubes are made, what they do is they have a little ring in the top with getter compound in it. And first they vacuum the actual gas out of it. So usually they heat the inside of the tube with a thing called an induction heater. They heat it up and they get the internals really, really hot, right? And that also gets the rest of the atmosphere that's in there moving around. And then they vacuum it out and seal it up. And then what they do is they actually bring the induction heater over the getter ring, which is right here, and it gets it hot enough that it flashes the getter compound onto the internals of the actual bulb. And that's this little chrome spot that you see here. So a lot of the times when a light bulb fails, it looks like it actually getters the inside of the bulb. Well, in this case, when you see a chrome spot on the inside of a vacuum tube, that actually means that the vacuum tube hasn't come to air. Now, what ends up happening is, or comes to atmosphere, what happens is if there's a crack in the bulb or there's a stem leak, like a stem seal leak, or a leak around the pin or anything like that, this stuff will go white. inside. So you can look at this chocolate brown as kind of an intermediate state. So this tube has definitely been, in here for a while, and usually in hard service when they have that kind of a chocolatey brown ring. Doesn't mean the tube is bad. There still may be quite a bit of life left, but you can tell that it's about midway through at that point. So there's a little bit of tube knowledge for you. So in order to find the issue on here, I'm going to get a piece of paper and I will draw out what is happening here. So I got the paper. It should knock down the exposure quite a bit and cause it to focus hunt like it's doing. Isn't that nice? So usually what happens is you have the wall plug here, and then you have a switch. And then what happens is you have the vacuum tubes all along here like so. And I'll just draw 3 of them to make things easier. And then you have another one here with a filament, another one here with a filament, and then it comes back around and comes here. So you close the switch, and all 3 of these filaments would have to add up to 120 volts AC, and then of course the current of the filaments would have to be the same. Just for argument's sake, we'll say 60 milliamps. So each one of them would have to be 60 milliamps each, because if one was 120 milliamps, say this was 60 and then 120 and then 60, well, what's going to end up happening is this tube isn't going to light up very bright, and these 2 are going to get very bright, and what's going to end up happening is these 2 are going to burn out. So the current of all the tubes has to match throughout the string, and in some cases where they've had a little bit of a current mismatch, sometimes they've even put a resistor across the actual filaments to try and to make things equal. So if the rest of them, say this one isn't drawing enough current, they'll put a resistor across it to mimic drawing more current so that the rest of the string gets happy. So there's all sorts of tricks they've done in the past in order to make this happen. So at any rate, so what happens is how we test the tubes in circuit is really quite simple. So we have a series string. This is like an old series Christmas light string, okay? If one of the filaments opens up, none of them light up, right? Because they're all in series. So we'll say that this filament here, I don't have an eraser in here, look at that. Say this has a break in it, okay? So what we want to do is we want to take an AC voltmeter, right? It's a standard AC voltmeter like this fluke right here. Okay, and then what we'll do is we'll look across these filament pins, and it should be 0, right? Because this looks like a dead short, right? Because we have, you could classify this as an extremely high impedance connection and an extremely low resistance connection, or high resistance and low resistance, all right? Because this is open at this point. So if we put our voltmeter across here, it should read 0. And if we put our voltmeter across this one and this one, it should read 0. But if we come across the open filament, we're going to have the full line voltage across it because it's open, and these look like low resistances compared to the resistance of the meter, the internal AC resistance of the meter, or AC impedance if you want to look at it like that. All right, so that's pretty easy. So all we got to do is, these are 7-pin tubes. So I will grab one of these here. So these are 7-pin tubes, right? And it's very common with all these All-American 5 or All-American 6 style. So you have 1, 2, 3, 4, 5, 6, and 7, right? You count this way. So this is 1, 2, 3, and 4 are the filaments in all of the tubes on this circuit board. So we count 1, 2, and then go 3 and 4, and those are the filaments. So what we want to do is put the voltmeter across these 2 on each tube and look for the line voltage. All right, so what I will do is put this back in, get the circuit board here, and get the voltmeter all set up, and we'll check things out. All right, let's find the bad tube. So these are all the tubes here, so you just look for this little design on the bottom, as you can see, and then you look for the open area, and then of course you count clockwise on each socket. So there's a tube here, here, and there's another one here, another one here. So you can see all the tubes, and what we want to do is basically just find the one that has voltage across it, and that one will be the one that's bad. So we want to look for ones that have no voltage. All the ones with no voltage will have an okay filament, because the filament, of course, will look like a short. Now, I want to warn you, if you're following along, you're doing so at your own risk. You need to be very, very careful. When I turn on my current limited isolation transformer and variac supply, this is going to have about 90 some odd volts on this entire circuit board. And if I was to rest my hands on this, that wouldn't feel very good, okay? So if you're unfamiliar with the designs and how this works, you definitely want to do some more research into these radios before you start working on them. So again, if you're following along, you're doing so at your own risk. Be very careful. So on goes the isolation transformer and current limited variac supply right now. So this would be the opening here. So this is pin 1, 2, 3, and 4. So let's try this one here. And as you can see, there's nothing there. All right, so that tube is okay. So we'll go, this is the opening, 1, 2, 3, and 4. Nothing there. So that one's okay. Let's try this one here. So this is the opening here. So 1, 2, 3, and 4. So steady my finger here. Nothing there. Opening here, which looks like, yeah, this is the opening here. So it's 1, 2, 3, and 4. Okay, so I'll go here. Nothing there. Opening here, 1, 2, 3, and 4. Let's see what this one is here. And there's our problem. All right, so the filament is open in this tube. So if I was to actually short these two pins, all the rest of the tubes would light up. But of course they would get a little bit bright because this tube has a 12-volt filament in it. So it would be, the whole string would be short 12 volts. So everything else would get that much brighter. So this is the bad tube right here. So what I'll do is I'll turn off the isolation transformer and current limited variac supply. Since the tubes aren't lighting up, the capacitor, the electrolytic capacitor in here won't be charged, because the tube needs to light up and be in emission for that to happen. So I'll just move all this out of the way. And look at that. That's kind of interesting, eh? So this is the bad tube, and this is the detector, AVC, and audio tube. So this is the bad one. This is 12AV6. A 12AT6 will also work in this socket. The AT has a little bit lower gain in the triode, and that's about the only difference in the actual vacuum tube itself. So somewhere in this tube, you can see those two little white strings in the middle there. Somewhere in that area right there in the cathode sleeve here, there's an open connection. All right, so these two silver things that you see in here are the diode plates. In the center is the cathode, so that's a common cathode between everything, and you can see a little bit of white emissive compound at the top. And then right in the center is the triode. So this is a little triode right in the middle right there. You can see the grid posts down in there. If I get something to point to, you can actually see the grid post there, and then right in the center is the cathode. So I need to look for another one of these tubes, and I also need to replace this filter capacitor. So I want to do that before I even power the radio up, because if this filter capacitor leaks or just fails the moment I power it up, what I'm going to do is I'm going to blow the bonding wire from the cathode to the lead out pin off inside this vacuum tube, so it'll just destroy this tube as well, and I don't want to take that chance. In any of these older radios, the very first thing to do before, of course, verifying the actual radio itself is to change the filter cap. If you leave the old filter cap in, you will destroy other things. So I'll explain more about that when I come back. So I'm going to go look for that replacement tube right now. All right, let's remove a capacitor. So what I'll do is I'll trim a little bit of the access lead length off here because it doesn't need to be all that incredibly long. Put this on here like so. Vacuum that out. And vacuum this out down here. And vacuum this over here. Lots of solder on there. So there we go. Ooh, that's not looking very healthy, eh? Cleaning the chassis is actually pretty easy. It's WD-40. I'm almost out of this. I'm gonna have to go get some more. Just spray a bit of it on here, and then grab a toothbrush and just gently work it away. You can already see it's already cleaning up very nicely. You can see that there. It gets rid of all the gunk and garbage on there. And it's just a time-consuming, tedious process. Now you can see I've removed the antenna that was here, and I also left the IF transformers on here just for reasons being is that the traces on these boards are very fragile, and I figured, you know what, if I'm careful and just brush around the base, it shouldn't be a big deal. So whether this has silver mica disease, I really don't know, so you may have to open these things up anyways at this point. Who really knows? So what I'm going to do is I'm just going to sit here for a while, and I'm going to brush this and clean this off. And yeah, I'll be here for probably an hour or 45 minutes, something like that, and cleaning this out. And once that's all done, I'll be back at the bench again and put some caps in this thing right over here, and we'll give it a try. Maybe it'll work. As you can see, the circuit board came out pretty nice, cleaned it up really good. So now what I need to do is add some new capacitors to this area here to replace this this crusty old capacitor here. So I'll grab some new caps and get those installed, and I'll show you exactly what I've done there. I think for the capacitor replacement, what I'm going to do is the original capacitor, soldered into these holes here, so it goes in like so, right? So this is the negative, and then we had two capacitors here. So what I think I'm going to do is I'm going to just rewire some of the traces on the bottom of the board, and I can fit 3 electrolytics here. The reason I'm going to use 3 is because this has got a 100 at 150 in here, and a 50 at 150. So I have 47s, lots of 47s. So what I'll do is I'll put 2 47s in for this value right here, and then I'll put 1 47 in for the last one. So that'll equal 3 capacitors, and that'll perfectly fit these 3 holes. Like so, and like so, and like so over here. The new capacitors are installed, and it almost looks like they were designed to be there. So that worked out very well. And on the bottom, take a close look at the traces. So all I've done is I've just cut traces, and I've bridged them to where they need to be, and I've used the pads to put the capacitors in. So that worked out very, very well. So if I ever wanted to remove this, it would be very easy just to desolder the capacitor right at the bottom where it's soldered into the pads, and just leave the wires, the existing wires there, and I could just pull this straight out, put a brand new one in, and just solder the 2 leads straight down into there. So that works out very, very well. Very easy replacement, and of course, these are very standard nowadays, and nice high quality capacitors right there. So now I found a bunch of tubes here. First of all, I was looking for the brand new 12AV6. So I found a brand new, and it's a General Electric tube too, which is kind of nice. So brand new GE tube for a GE radio. Not that that really matters or anything, but anyways, it will fit right down into there like so, and pull a shield up and lock it into place. Now, since I was looking for that, I came across this, a brand new 35C5, which is this tube here that looks to be awfully tired, and they often are. So what I'll do is I will put a brand new Raytheon tube in there. So brand new Raytheon tube. It'll be nice, strong audio output tube, just because I have lots of tubes, and why not? So I'll just put that in there. These tubes here are the ones that I guess you could say age the worst, I guess, in this particular type of radio. These get very, very hot, and this one here is the power supply basically for the entire radio. This is the rectifier, so this feeds current to everything in here. And then of course the audio output tube gets extremely hot. It's driving the audio output transformer and things like that. And of course it's running in Class A, and it's a Class A type amplifier, so it's giving off the heat, as you can see on the board, right? So the nice thing about this particular type of radio is that the capacitors on here are just disc style. They're not the paper and foil type, so they don't leak. So basically all the capacitors should be okay. So what I'll do is I will reattach the antenna here. I'll just tack this into place over here, the wires from the antenna, and put some power to it, and I'll see if this thing comes to life. So let's, what do you think? Do you think it's going to work or not? Well, let's find out. Okay, so I've got the antenna just tacked into place. I have my test speaker attached to the audio transformer here. It's a horribly ugly test speaker, which I'm going to restore very soon. So I'm going to take this thing and glass bead blast the case and paint it up. And you might be interested in seeing that restoration as well. Maybe I'll do that next. So I've been putting that off for a long time. But this thing here is, it's very, very ugly test speaker. So anyways, sits off to the side and makes noise. That's what it does. All right, so I'll turn on the isolation transformer and variac supply right now. Same one that you saw earlier. And we got a flash of the light here, which is normal. So that means that the filament string is working. And now all we have to do is wait and see. So give it a bit of volume, see what happens. All right, I can probably click this through. I don't need this on the current limited setting right now, and this way I'll get full line voltage to this thing. Full line voltage is a good thing. These capacitors are way overrated, by the way, too. So there we go. We have hum. That's full volume. That's definitely working. And absolutely nothing. Tone control. Yeah, the tone control changes the pitch of the hum, so the tone control is working. It doesn't look like anything's happening. Absolutely nothing is happening here. That's not a good thing. All right, give me a moment. I'll go get some test equipment and we'll see if we can see what's happening here just quickly. I have the Carlson Super Probe attached to the tuning capacitor here, so I'm just using the ground, the shell ground of the capacitor here. And this is much easier than firing up an oscilloscope and looking to see if the oscillator is working. I can just go close to the tube and the coil, and if this green LED comes on that you see right here, that means that the oscillator is working. So you can see that the oscillator, and this is the oscillator coil right here. Now if I move around anything else in the actual radio itself, you can see that nothing is lighting the green LED up at all. It just stays dark, right? It's touching this tube here and over here and over here. But if I get close to the oscillator coil, it lights up. So that tells me, right now this is detecting the RF, or the oscillation right now, okay? So it's telling me that the oscillator is working. So what do we know already? Well, we know that the audio section is working because we hear this horrible hum in the radio right now, and I can also vary the tone. Right, so this is all working. There's no problems with the audio section, and we know that the oscillator is working, and we don't know if the RF section is working yet. So if the RF section in here was completely not working, we would still most likely hear some form of a radio signal, or something when we turn the band, right? We'd still hear something little. The fact that we hear absolutely nothing, yet the oscillator is working and the audio section is working, tells me that the problem is going to be in the IF. It's between the oscillator and the audio section somewhere. We'll worry about the RF amp in a bit. That probably is working. All right, so we'll end up finding that out. If it isn't, we'll fix that too. So what I want to do is I want to look in the IF section here to see what's missing between the oscillator and the detection in the audio section. So what I'm going to do is unplug all of this. I'll flip this upside down. The very first thing we're going to do is check the windings on these IF transformers, and we'll see if they're intact, and then we'll move from there. All right, let's test some IF transformer windings. So short the leads there, you can see. All right. So you're probably wondering about this meter. Everybody always asks about this. It's just a remote wireless meter, so it allows me to fit this into the area and have the rest of the meter out of the area. That's all. So I can, focus in a little bit closer to things. All right, so the windings on these go on the long side. So you'll see that these are closer together this way. So the windings are like this. This is one winding and this is the other. That's how these work. So let's see if this winding is okay. Well, that's not looking very good, is it already? See this one here? Yeah, there's a winding there, and there should be a winding right here. And it's not looking like there is. So let's test this one at the bottom here. All right, so there's a winding there, and there is a winding there. So look at that. The very first thing we tested, we found the problem. Okay, so yeah, no problems there. So 9.1 ohms there, and this one here was what? 46 ohms here. This one side was okay. This would be the secondary side. This 15 ohms, and then this one here is open. So that's why we're not getting any radio happening. So yeah, so this is the other IF transformer. In fact, I was testing the RF transformer. Let's test the other IF transformer. How about that? So here we go. Is this one open too? No. Can't be. I'm testing the wrong way. So it's this way. And let's see if this one here is okay. This way. There we go. Yeah, so no problem. So this IF transformer is okay. This RF transformer is okay. But the first IF transformer has an issue on this winding here, so on the primary. So what I'll do is I will remove this IF transformer. Let's open it up and see what's inside. See if we can fix that open winding. All right, let's try to remove this IF transformer without removing any pads. And you can see this here. These copper traces are paper thin, like I mean incredibly thin. So these early circuit boards are not flexible at all. And this here is basically, it just sticks through and they solder this to this. So this holds the antenna. And just from movement, this was already ripped right off. I noticed that earlier. This was already ripped right off. Of course, the trace was still there, so you really couldn't notice it. But of course, when you desoldered, it just came right off on the pin. So this was loose to begin with. So what I'm going to probably end up doing is putting a brass screw through here. And then I'm going to also do that with this area right over here. I'll put a brass screw through this. And then I may somehow extend this, maybe the brass screw up through here, bend this over, and then solder that to the brass screw on the top side of the chassis, and that'll make this very mechanically strong, so it will stop breaking. So I'll figure out what I'm going to do with that. Once I have that all figured out, I'll share that as well. So that, as I say, the traces on these boards are very, very, you know, if you excessively heat anything, they'll come right off. So what I'll do here is I'll add a bit of solder, because that makes things desolder that much easier. So I add a little bit here and here, mixes in with the old stuff, and here and here. So I have my iron right now set to about, what is it, 370 degrees C. That's where my iron is set to. That allows me to keep the dwell time down. So let's see what happens here. So now what I'm going to do is, because I don't have my large tip on here, I think what I'll probably do is just be very careful with this. You can see that it's pretty much removed all the solder there. And of course there's still always some stragglers, or sometimes it does have stragglers that hold it in. And then what I will do is heat this area right here just a little bit, and hopefully that'll allow me to get this out of here without too much damage. As I say, these traces are so thin, and they really are a pain. So I just want to make sure there's nothing else holding this. It's usually just one side that they have. It looks like this is all loose. It just looks like this is the only thing holding it. So give that a bit of heat. Rock it around just a little bit. And it doesn't look like anything else is holding it. Very tight fit in this old circuit board. I don't know if you can see that there. I'm looking at this off camera, right? There it is. Popped out. Actually, the top of the case came off. Well, it just makes things easier for us to get into the transformer with now. So now I got to be really careful. So this is all loose now, very loose. Actually, I could probably just push that out. So I'll just use this here and very carefully pop that out. It's odd how that came apart in two pieces. Very strange. Okay, so what I'm going to do here is see if I can find the open. Look at that there. Looks like it's a little bit green. So what I'll do is zoom on in as far as I can. So that looks like that might be the problem right there, eh? Possibly. Oh, there it is. Look at that. There's the open right there. It looks like it's corroded. Do you see that move? Just grab my pin vise here and just show you that. So you can see this here. See that right there? That's where it's open. Kind of green. So, and that would attach to this right here. So that would be the primary. So what I'll do is I will reattach that. And we'll see if we can get any radio signals happening here. So it's odd how that came apart. It's just, you know, it popped out of the case. And it's only held by this. And yeah, and then the other thing just comes out of the board super easy. Very, very strange. So usually when these things get silver mica disease, they have an issue with a capacitor that's buried down inside. And as you can see, this is a capacitor right here. And we have another one on this side. So hopefully we don't have any silver mica disease in this. It looks pretty good. You can see that there? Looks pretty good in there. So I think we might be okay. If it does, well, then we're going to have to do some augering. And I'll have to put some capacitors inside these things. All right, I just finished soldering this. Let's see what happens. So this is one side, 16.8. And we'll go to the other side. And 15.3. Success! So, let's put it back in and see what happens. Let's solder this thing back in. So here we go. Alright, lots of shadows and everything there. Okay. So what do you think's going to happen here? Let's see what is going to happen. Let's just attach the antenna. Just tack this into place. Nothing permanent, just something to try this out with. It'll stay enough that it'll make connection. And same with this. All right. Okay, now speaker connections. Grab this out of the way. So do you think this thing's gonna work? I hope so. See the speaker connections here, just attached up. Move that there. And reattach this. Make sure all the tubes are straightened up. Okay, here we go. Let's see what happens. I don't know if I should leave the volume totally turned up because it might just come to life and get really loud. Who knows? So, zoom on in here so I can see this a little better. So move this up just a touch. Hey, that sounds more like it. That's me touching the antenna. I took one of my little alligator clip wires and just wound a bunch of turns around this end of the rod antenna. Just very crude, just to get some signal in here so we can actually see how well the radio works. So I'll turn this up a bit. Attach this here. Look at that, it actually just, it comes right to life.
Down conditions apply. Your home of the Canucks. In the Dobbs case, which could well overpower. Not bad, down there.
So not bad whatsoever.
Here. This is this idea that you could treat and more reliable than other platforms.
So it's working very well. So the next thing to really do with this is to give it an IF alignment. So I imagine this will be at 455. It's pretty standard. And then I will align the RF as well. I'm now ready to perform the IF alignment on this radio receiver. And in order to do that IF alignment, I have an RF signal generator attached to the radio, and I'm also using a VTVM. I'm going to use this to peak up the IF. This VTVM is in parallel with the speaker that's off to the side here. So right now, I'm feeding a 455 kilohertz signal into this portion of the tuning capacitor. This portion of the tuning capacitor is closest to the grid of this tube, so I'm bypassing the RF amplifier stage right here. So the signal is coming through here, going through a 0.01 microfarad capacitor into the tuning capacitor. The only reason I have this capacitor here is to block my signal generator from the radio or the device under test. I don't want any direct connection just in case something goes wrong. I don't want to take out the front end of my signal generator. So a little bit of protection right here. The ground I'm using is the actual circuit board ground, not the ground on the tuning condenser. If I ground the signal generator to the actual tuning condenser, what'll end up happening is I'll get a lot of hum on that signal, and I don't want that. So I need to ground the actual signal generator, the 455 kilohertz signal generator, to the chassis or the circuit board ground. All right, the device under test here is attached to an isolation transformer because there is no transformer here, and that's very important in order to basically isolate this. We don't want any, connection to any AC line directly to the actual AC line or anything like that. So whenever you're working on an All-American 5 or an All-American 6 style radio, an isolation transformer is a very important safety consideration, and I do quite a bit of talking about isolation transformers in many of my restoration videos and things like that. And of course, I recently talked about this on Patreon as well. All right, so this is the tone that we're listening to. So that's a 455 kilohertz tone modulated to 50% by a 600 cycle tone. So the 600 cycles is what you hear. The reason I chose 600 cycles is just because the microphone picks it up. You can use 400 cycles, or if you have a signal generator with a fixed audio tone, whatever it makes, it's absolutely fine. A kilohertz, whatever, 1,000 cycle tone, whatever works. Okay, so I just have 600 cycles here. Now you'll see as I turn the volume up, because this is in parallel with the speaker, you'll see the actual needle moving up. Now, because the speaker itself is loading the circuit and we don't want to listen to that, I'm going to remove that, and you'll see how much more sensitive this gets. All right. Now, as long as the audio level in the radio is at a moderate rate, at a moderate level, it's not cranked up incredibly loud. Having no load across the audio output transformer, aside from the VTVM, is absolutely fine. This is done all the time. All right. It's absolutely safe, and this is the way it's done. All right, in order to get the sensitivity out of your VTVM. All right. So what I'll do is I will turn this up to just about halfway. Okay, so I'll turn the volume up just a little bit. And what we want to do is we want to peak this up. So this is the IF transformer that was just repaired. So I want to turn, this has an upper and a lower slug. So what I'll do is I'll slide this into the upper slug, and then there's one on the bottom, and I'll slide this through. You'll see the shaft diameter here is a little bit smaller than the adjustment. So I can slide this into the upper slug and adjust it, and then I can slide it through the upper slug down to the lower slug and adjust it all from the top side. So that's what I'm going to do first here, okay? So what I'll do is I'll give this top one a bit of a twist, and we want to peak this up. Let's see how close we are. Looks like I'm pretty spot on, doesn't it? Okay, so now I'll go to the lower one. I can feel it lock into the lower one, and I'll move it. And this one here is right on. So I want to bring that to the absolute peak that I can. Move that upper one again. And that's about peaked. All right, so this one is pretty well in adjustment. Let's see if this one is, the second IF transformer here. Ooh, that one's way off. Okay, so this is the upper slug here. So I'll have to turn the audio down. Turn it back to about midway there. And I'll keep adjusting this. All right, so there's the peak there of the upper slug. Now I'll slide this through to the lower slug and adjust it as well. And it was out, but not so bad. Go back to the upper slug. Try again. Alright, so we just gained a whole lot of sensitivity. So now what I'm going to do is I'm going to turn the actual signal generator down. So I'll turn this down so it doesn't get too loud. Okay. So now I'm feeding this with about a 500 microvolt signal. Alright, so what I'm going to do is go to, say, 300 microvolts. Let's try 100 microvolts. 200. Alright, 200 is about good. Alright. So I don't want to overdrive this and, start working the AVC action or anything like that. So what I'll do is I'll remove this again, and I'm going to adjust this again with the signal level reduced. Okay. I'll turn that back up. Make sure that I'm getting the absolute peak. I want this to be as sensitive as possible. There's a little bit of a gain there. You see that? See that? And go back to this one here. And go down to the bottom slug in this one. And we gain just a touch. Alright, there it is. And go back to this one here again. Try one more time. And go down to the bottom slug in this one. Back to the upper slug. And that's about as sensitive as this is going to get. So the IF section in here is completely aligned. So now that that's done, we're going to have a big increase in sensitivity. Now I need to focus on adjusting the RF section. We'll do that next. The dial tops out at this point at about, 1568 it tops out, so 1.568 megahertz. It doesn't make it to 1600. It's supposed to make it to 1600 because the oscillator's out of adjustment. So when this is back in the case and I do the alignment for the needle, I'll adjust that then. So this adjusts the oscillator. This one here adjusts the antenna, so it keeps the antenna peaked up, and this adjusts the RF section. So this here needs to be adjusted at the upper portion of the band. So we can just try to adjust it at 1568 and see what it does right now. And then in the end, I'll readjust it again. It's a pretty broad adjustment, so I probably won't have to readjust it, but I'll do it anyways just to make sure everything is peaked up. So right now, the signal that you hear running into the antenna is 10 microvolts. That's a 10 microvolt signal. And it goes down to 1 microvolt or lower, and it still hears nice. So very sensitive receiver, very sensitive old tube receiver. Okay, so what I'm going to do here is I'll disconnect the speaker again, and I'll give it just a touch of volume, and we'll peak this up with that tone there. Okay, so it'll rise pretty quickly. That's all right. So it's going to move around just a little bit because of the noise in there. So what I want to do is peak this up. So see how close it is. All right, so there, I'm in the slug, so I'm going to turn it now. And it's going down and coming back up and going down again. So right about there is the peak. And it was perfect. So this one here hasn't been screwdrivered. So this one here was, and this one was way out of adjustment. So this one was close, I should say, very close. And then this one here was out to lunch. So, somebody may have been in here at some time and screwdrivered things around, but they got this pretty close. This is a pretty easy adjustment. You can pretty much do this with a radio station close to the top end of the band. So just, basically, you're looking for a weak signal at the upper end of the band, and then you just tune this for a peak. Of course, I'm doing this with a signal generator. That's the proper way of doing it, but there's, ways around these alignments to make things just a little bit simpler. So the next thing I need to do is clean the case up and do all that stuff and get this back into the case so that we can do the dial alignment. And once that's done, then I can peak everything else up and we can give it a performance check and see how well this thing works. I have a feeling that this radio is going to stand up to its name. It is a long-range radio. Well, I gotta say that this is a pretty dirty looking case here, so this definitely needs to get cleaned up and something done with the foam. It looks like you could actually put another speaker right here, which is kind of interesting. It has the clips for another one, so I guess they've had this maybe filled with foam, or maybe it was just around the edges, because something is missing in here. So I'll probably find another piece of foam and tuck it in here. I think that's probably just to deaden maybe the sound that comes back. Who knows what's going on. So obviously they did a little bit of research in that. So I think what I want to do is get the speakers out. So if I press these tabs carefully, I can remove the speaker. Yeah, it's in perfect condition. I'm going to test them too to make sure that the voice coil isn't rubbing against the magnet. Stuff like that. This one here was really loose before. I think I can probably get this one out with minimal effort. Aha, look at that. What does that one look like? Oh, it's pretty mint condition as well. So I'm going to move these out of the way, and I'm going to put them in a very safe place, because if you've worked at the bench for any length of time, you'll know that screwdrivers will walk across your bench and puncture speakers. That's the way they target them. I don't know, it's kind of weird. You'll leave your bench for 5 minutes and all your screwdrivers are poking the paper of the speaker. It's just kind of a weird anomaly. So when you remove speakers, always get them off the bench. So I think maybe what I'll do, I can maybe twist these. I don't know if I want to take that chance. Twist these back to remove that metal grill on the front. Maybe I'll just work around this, try and get this out of here, and maybe tuck a piece of foam in there or something like that. And clean out the inside, maybe clean the case, get that sticky residue off there. And yeah, General Electric tag looks like it's a bit crooked. So maybe I can fasten that on there. There's nothing worse than a crooked label like that. That's just, you know, if it's perfectly even, you're like, oh, that looks good, right? You know, when you find something like this from the factory and it's crooked like that, I don't know, that just, to me, it's always like, quality issues. So I'm going to do that. I'll get that done. And then, of course, I'm going to polish this as well. I got this plastic cover that looks pretty scratched. I don't know if you can see the scratches in that. So try and polish that up a bit too. And maybe it'll make viewing the stations just a little bit nicer. You can see how gross that is. Yeah, that'll definitely need replacing. I've been working away at the top of the case here, and I've got that tape residue off pretty much. You can see there's still a little bit left there. Just with some rubbing alcohol on a paper towel. I'm just working away at everything on the top here. So I just want to get the sticky residue off first, and then after this point, I think what I'm going to probably end up doing is using some Vim. And I'll go over this with some Vim. It's a little bit more aggressive than rubbing alcohol to get, you know, rid of this kind of stuff. And that's pretty stubborn. So I'll see how that comes out. So that got rid of the tape residue at any rate, and that was pretty bad. No more sticky residue at that side. And I'm not really sure what this stuff is. It might be dried on residue from a long, long time ago as well, but it does seem to be coming off a little bit. Yeah, it's coming off. So maybe this will come off as well. So I have to be very careful. I'm putting a lot of pressure on the plastic and I don't want to crack it, so I gotta support this here. And the alcohol seems to be working pretty good, so I'll just work away with this for now and see how well I can get this, because this is probably the, I guess you could say, the least aggressive. I think Vim would possibly take a little bit of the shine away. So, you can still see it may need a bit more scrubbing. So anyways, I'll work away at this, and I'll also work away at the inside here as well, and clean it all up. And I found a piece of foam, so I'll put this piece of foam in there, just a junk piece of foam. There's some sticky glue on it, so I peeled the glue off, but it should be okay inside there. So that'll be installed in this little area right here. Alright, so I've bent these little tabs, so basically you just have to twist them back into place. I figure I better take the grill off because I'm going to pretty much have to soak this thing in water to clean out the insides. So just give it a bit of a push, and that allows me to clean this as well, and possibly even fix this and get that really straight. So these are all the little tabs that poke through the plastic here, and you just give them a twist and that locks it into place. You know, of course, just really quick assembly, and as you can see, the foam residue that's still there. So this will allow me to clean this quite a bit better. So that's what I'm going to do now, is just pretty much put this thing in a sink and just with a toothbrush and work away at it. The case came out very nice, so a little bit of scrubbing, and it came clean. No problems there. So that's the case, and then what I did with this is I sprayed some Fantastic on this. I took this off, right? You just bend these tabs back and that comes off. And I sprayed some Fantastic on this, let it soak for a while, and then just rinsed it off and carefully dried it with a hairdryer. And it turned out very nice. So that will go back on here. So it's coming together very well. So now the next step is to take that piece of plastic and polish it up, try and get some of the scratches out of that. So we'll take a look at that next. The first thing I've done is I've taken some Windex and just cleaned this off to get rid of all the surface debris. And the next thing I want to do is put a bit of plastic polish on this. And I am just going to work this into the plastic. So I'll be sitting here and just working this in like so for quite some time. And when I get some results, I'll be back. Well, it turned out actually very well. As you can see that there. There's a few deep scratches in there, but when this is up against the dial face, that'll be absolutely fine. So that's quite a bit of polishing to make that come up to that particular point. And there's a weird kind of almost like a smoke-like grain in the plastic. I guess that when they molded the plastic, maybe the actual mold was a bit dirty. I don't know if I can even get that in there. I don't know if you can see that. Let's see if I can get that smoke-like grain like looking in there. Now you can kind of see a bit of it in there. Under the right light, you can really see it. So there it is. You can kind of see this here. Let's see. There it is there. I can somehow make this show just a little better. I've cleaned it too well. You can't see it anymore. There it is a little bit. So you see that? It almost looks like a grain right in here. See that? That's right inside the plastic. So that might have been in the actual mold itself. I really don't know. You can see a little bit of it here. That's inside. Actually right in the plastic itself. So that is pretty clear. I don't think I'm going to go any further than that. So I'll get this back on the radio. And we'll do some other testing. We'll test the speakers, and I'm going to change 2 capacitors in there with X1, Y2 rated capacitors. I'll show you that on the chassis just before I go about reinstalling it. And at that point, it's pretty much ready for final alignment. Let's test some speakers. So what I've done is I've disconnected the wires that hook both of the speakers together because they're attached in parallel. This way I can listen to the speakers individually. What's kind of interesting, I've noticed, is the red wire attaches to this terminal, which attaches to the speaker frame. Usually, that is speaker negative, and the other one is speaker positive, but who knows what they've done here. Maybe, for some reason, the speaker is reversed. So I'm going to also test them for phase. I'm going to make sure that they're working together. I don't want them to be out of phase with each other. So they both need to push at the same time or pull at the same time in order to sound good. If one's working against each other like this, we have issues, so it'll make the radio sound kind of hollow. So it's very important to test speakers. So I have a 200 cycle tone from my signal generator. It's a very low amplitude attached, and I'll attach it to this. Listen to that. So we thought that that speaker was looking absolutely perfect, and it does, but sounds like this. So if I would have put this speaker back into the radio, it would have sounded absolutely horrible. And this is a pure example of why it's so important to test a speaker. Well, this is actually quite a simple problem to fix. The paper has actually come unglued from the rim all the way around. Look at that. So the whole speaker is just kind of buzzing against the speaker frame. So this would actually make a very nice buzzer. Nice, very low amplitude, and listen to how loud that is. Like, it's just make a really good buzzer. So what I'll end up doing is putting some glue under here, and then, of course, having this on a flat surface, put some pressure on it and let it set, and that should be absolutely fine. And I'll retest it before I install it. Let's test this one out here. So this is at 200 cycles as well. This one sounds not bad. You can tell there's still a vibration in there. So if I touch here, the vibration pretty much disappears. And if I push up here, I'm just touching this. There's hardly any pressure at all. So I'm going to need to look into fixing this one as well, because I want this radio to sound incredible and not have a buzz in it. So I'll get both of these speakers fixed, and I'll show you exactly what I've done. Alright, this was a little bit difficult to do on camera, so I'll just explain what I did. It's actually very simple. So what I did is I had a pair of gloves on, and I pushed the paper out. So I hold onto the frame, and I push the paper out so the cone extends out, so the whole rim lifts all the way around. So it sticks out about, I'd say that much right there. So the smallest gap between my fingers. But right there. And then what I did is I put super glue under the entire rim, and then I let it back down, and then what I did is immediately put it on a piece of paper, and then I have this stuff. This is an instant activator. So what I did is I sprayed the paper so it instantly soaks the paper from the backside, and what it does is it causes that super glue to set immediately, so it holds it nice and tight. So that gives me a little bit of time to get this off the paper so the paper doesn't stick to this, all right? And then what I did is I hit this side with the activator as well, and it immediately hardens the super glue, and that's the speaker fixed. So here's that same tone right here. Nothing's changed. Doesn't that sound nice? Definitely a lot different than before. So no problems there. It's working very well. What I did to this speaker here is, you'll notice in the earlier shot when I showed you this, what I did is I had a Q-tip and I poked around the rim, and in some areas it got louder than others, and then in one area it made it very silent. Alright, so, and I could just touch the Q-tip to that one point. So what I did is I got some rubbing alcohol, put it on here to wet the paper, alright, because rubbing alcohol dries up very fast. So I put rubbing alcohol on there, I put a bit of pressure on that spot, and then what I did is I took my heat gun that I use for surface mount work, and I heat the area like this so that the rubbing alcohol evaporates immediately, and that immediately puts that little bit of a pressure on this one side right here. Alright, so now that speaker is formed like that right here to correct what was buzzing. So now, what I'll do is I'll attach this back up. Again, nothing's changed. And you can hear how nice that sounds. No more buzzing there at all. So both speakers are fixed. I'm going to sweep them one time as well. So I'll just go through a whole broad range of frequencies just to make sure that they're okay, but I'm pretty sure they're absolutely fine. In fact, I'm 99.9% they're sure they're fine, but I'll sweep them anyways just to make sure that they're absolutely perfect. And then they will go back in there. And we also need to phase them. I'll show you how to do that next. Phasing a speaker is actually very simple, and they were pretty tricky with this one. Actually, the positive is connected to the frame, which is strange, and I'll show you why. So I have a rather tired 9-volt battery, all right? So I know this battery is okay to test these speakers with. And of course, if you're going to do this, you want to use common sense. Don't be attaching your speakers to a 9-volt battery for any length of time. And of course, you may want to use current limiting if you don't know the status of the battery. Okay, so if you're doing this, you're doing so at your own risk. But at any rate, what happens is if you have the speaker correct and you attach the terminals, you only do this briefly, the speaker should pop forward. All right, so if the positive is to the positive and the negative is to the negative, the speaker cone should come out. All right, and I'll give you an example of that. Okay, so see if we can get this in here so that we can see this. Okay, so I'll touch it here. See that? See how it's coming forward? So it's on now and then off. Okay, so that tells me that the positive is running to the positive and the negative is going to the negative of the speaker. So I'll reverse the battery's polarity here, and you'll see the speaker pull in. So that would mean that we have it hooked up backwards if this was in service. You see that? See how it's pulling in? All right, so that would mean that there's an issue. So the positive actually is the red lead, and it is connected to the frame, which means that this one's probably going to be the same. So let's try that out. All right, so this would be the positive then. Attach this to here. And since this one does not have any leads attached to it, I'll have to attach another lead. Alright, so let's see if this one goes forward as well. Okay, here we go. Yep. So that's a good sign that both of these speakers are actually the correct speakers for that radio as well, because that's pretty odd having the positive connected to the frame of the speaker. Usually that's, speaker ground. Before I put the circuit board back into the radio's case, I want to replace this ceramic disc capacitor. You'll see that it's directly across the AC line. Now, we have modern safety capacitors that are rated for that. These were just standard disc capacitors that they had way back when. Usually there were, high voltage rating like this one has. This is 900 volts, and it's a 0.01 microfarad. But still, the newer modern safety capacitors are designed to fail in a safe way. So these ones here have all the safety ratings. So I'm going to replace this with an X1 Y2 rated capacitor. And I'm also going to do the same with this one right here because it is across the AC portion of this tube. So it's actually running from the AC side to the DC side. So I'll get rid of both of these capacitors here. And that way, if anything does go wrong with the capacitor, again, they fail in a safe way. Usually when these old ceramic disc capacitors fail, they usually come to just a dead short. And of course, if something like that was to ever happen, well, what would it do? It would probably trip the breaker in the house, right? Or wherever this thing is. So always remember that if you have any capacitors, paper and foil or ceramic disc, or any type of capacitor that is across the AC line or from the AC line to the chassis, they need to be replaced with modern safety capacitors. That is always a must. The new capacitors are installed, and I still have to clean the bottom side of the board. The reason I haven't done that yet is because I'm going to end up resoldering every tube socket connection on the bottom here. Just because the solder rate from the factory is always a little bit thin, and there are some connections on some of the tube sockets. I resoldered this one here, and there are some of them that are very, very thin, and you can actually see this one's actually looking kind of cratered. So it's always a good thing to do. It takes just 10 minutes of time to go through and just look at that, how kind of thin that is on the solder there, right? So it just takes a little bit of time. Another really good thing to do is definitely resolder any of the controls that lead out. So, the volume potentiometer and the tone potentiometer, you want to resolder those because that's continually being moved, right? As you're touching it with your hands, it's continually seeing motion. And a lot of the times they end up cratering as well. And this one here looks like it is starting to crater. I don't know if you can see that. It doesn't show very well on camera. It's right around the pin though. So, yeah, so it's always just good practice to do that. And that way the radio will see a, really long service life after it's been restored. So I'll get that done and clean up the bottom here, and then we'll get on to the final portion of the alignment. While I was resoldering the tube sockets, I figured why not just resolder pretty much the whole thing. So I'd say 95% of this is resoldered. The rest of it was so good that I didn't bother. So now that this is done, I'm going to also spray some contact cleaner into the VRs, so the volume control and the tone VR, and I'll also lube up the variable tuning capacitor. I still have to put the two little studs in here to mount the antenna back on, and at that point this thing is ready to go back into the case. The radio's all put back together, and it's looking like it rolled off the factory floor, and maybe even a little better. I took the time to loom the wiring and things like that, whereas they didn't from the factory. So now that that is all done, the dial scale needs to get adjusted. So we need to make sure that the oscillator inside is tracking correctly with what's written right here. So what I need to do is get my signal generator ready, and what needs to be adjusted is that adjustment right there. So we'll get something to point to this. This adjustment right here adjusts the oscillator. So I'll be twisting this one here to align the radio electrically to what's written right here. The radio's been on and warming up for about 15 minutes. Before any type of an alignment is really done on a radio like this, it should be left to warm up for a while, the final alignment at any rate. So the first thing I want to do is I want to make sure that the dial pointer mechanically is going from end to end. So you can see how it's right at the end here. Say it stops at 1600 and goes all the way to, touches this end here. I would want to move this over a bit until it's centered so it stops evenly on each side. So what I'll do is I'll move this right up to the top end of the band here. And it stops perfectly right at the other side there. The band or the dial string just gets tight as it touches the end, so there's no problem. If for some reason that was out of adjustment, I can stick a screwdriver in there and slide the actual needle on the dial string over a little bit each way to get things centered. That's the very first thing that needs to be done. In some alignment procedures, they actually tell you that it needs to start at a certain point. And something like this, if it will travel from end to end comfortably, that's the way that you're going to want this thing to align it. All right, so I've got my signal generator attached to this, and I have it set to 1600 AM, so that would be right here. So I'm going to turn that on right now, and I'll turn the volume up, and let's see where this thing is actually sitting. So turn this on right now, and I give it some volume. And I'll move the dial pointer. And it is close. That is actually where it's supposed to be. In fact, right about there is where it should be. So in order to electrically align this, I need to bring the radio to 1600. So I need to put this into here and give it a twist until I hear the radio station. So hopefully I can do this on camera. It's a little bit on an angle here too. I need a shorter tool for this. So that's obviously the wrong way. There it is. Right there. That's exactly where it needs to be, right in the center. So the next thing I'm going to do is I want to see how the actual dial tracking looks. So I'll set this to, say, 1 megahertz. Give me a second here. I'll put this to 1 megahertz. So now I'll move this down here. Look at that. Right on 1 megahertz. So the next one, let's try it at, say, 600 AM. All right, so we'll go 600 kilohertz. Turn this down. Move this down to 600, so it should hear a tone rate at 600. Perfect. And we'll go to, say, 55, or 550, I should say. 550 kilohertz. And turn that up just a bit. No problems. So the dial tracking is working very, very well. So that's done at this point. Next, what we're going to do is we're going to peak up the RF and the antenna as well. All right, let's peak up the antenna and the RF section here. I have a feeling it's going to be really close. So this is across the voice coil of the speaker right now. And because the speakers are, in place and all the wiring is soldered, we get to listen to this wonderful tone. So in order to adjust the antenna, I need to adjust this one. I don't want to touch this because this is the oscillator. We've already done that. And this is the RF over here. So I'll adjust this one first. This is kind of a pain because it's on an angle. But we're looking for a peak. I think we are at the peak. Yeah, that's it right there. It is peaked. So not much has moved from that pre-alignment regarding this area here. So I'll give this a turn. This is the RF now. So you can see it went down a bit. And that's its peak right there. So the thing is completely peaked. And this coil here is still going to be peaked because it's beyond what we've done here. So this will still be peaked up. So no problems with that. So this radio receiver is performing the best that it can. The radio receiver is all reassembled and it's been warming up for a while. So it's nice and warm now. So we can cruise the AM broadcast band and see if this really is a long-range radio receiver. So I'm going to reposition the microphone so you can really hear the radio the way it was meant to be heard. So I'll get that all done and we'll get started. All right, here we go.
You're just pulling me down, even though I want to be positive.
What the entire process is about.
And that's key right now. Is there any consistency to it?
Gardeners extraordinary. The Toronto District School Board is asking mayor symbols, cars, you remember mayors? And we haven't quite got the conclusions.
Sits around quite a while, so, but again, all the credit goes to Arkansas. They're
9-year-old me.
So funny because Aussies are not big on hugs. If you know Aussies, and I know a lot of you know the brand.
Every day we hear of some new natural resource that we need to
Had a shadow band. And you get drop rotations, you get trace.
I bought for, this is a Calgary.
The other thing that the place, we built the restaurant from nothing.
888 loan, 866-888.
Just call me.
And a band. Subject to change. Equal housing opportunity.
We'll have a in 60 seconds.
When you're responsible. No.
No matter. Thank you.
LoanDepot.com. Loan Depot. Wells Fargo Center in Philadelphia. How it's going to play out with Edie and
Last
Wow, listen to all the stations this radio is pulling in. It really is working well. So we'll go back this way, try one more time, take a listen here.
don't, and you're not going to. She was lying at Cronin does to provide and help his team with matchups. You missed, you're not getting the ball. UCLA's 22-0.
I think by her being here,
Sure.
I was able to help me be more productive. And
Cruz working on the 91 for the Alex Fraser break.
We mentioned Hawkins. The goal is a huge player for those 470
Patriots that
So you're making plans.
Number one, be loving, unselfish, and kind.
Trying to bring some of the inspiration of Sucre, Buenos Aires.
$299 for 24 individuals.
With how she was with him on this trek, and
At least another 5 years in the league, whether it be...
I don't... If the man can get the same run, if the man can get...
Today, all they'd have to do is to go to...
Colonel, Kevin, what do you have for our weekly UFO report?
Said at the end of your previous answer that you
pinned to the top of our Facebook.
NATO leader Thursday to coordinate the military alliance.
Morris on the logo. His pass knocked away and
Interim stops that refugees have to make as they're processing.
But I truly believe that the far left, just
a 36-year-old
has been charged.
You know what? On that subject of
Doesn't play any reality, the body eventually dies, and
ਜਦੋਂ ਆਪਾਂ ਉੱਤੇ dent
the body eventually dies. That's a biggie.
It's
The body eventually dies.
that term, need
Wow.
love versus real love.
right.
Here, like, the radio stations are actually just a little out of sync, I guess, in time between three radio stations playing the same thing. That was kind of interesting.
Feeling like you're not enough standing alone. You're feeling you don't have the value. You're looking for what they can give you. But real love doesn't look like that.
Well, I have to say that this radio receiver is working absolutely fantastic. And yes, it really does hold up to the name long range receiver, because a lot of these radio stations are coming from very far away from here. So it is working very well, and I would definitely say this is a project successful. If you're enjoying my videos, you can let me know by giving me a big thumbs up and hang around. There'll be more videos like this coming in the near future. We'll be taking a look at vacuum tube and solid state electronic devices alike. So if you haven't subscribed, now would be a good time to do that as well. If you'd like to be notified as soon as I post a new video, don't forget to tap that bell symbol. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way, and gaining access to many of my personal electronic inventions and designs, you're definitely going to want to check out my ongoing electronics course on Patreon. I'll put the link just below the Show More tab below the video's description, and I'll also pin the link at the top of the comments section, so if you click on the link, it'll take you right there. Alright, until next time, take care. Bye for now.